Hey makers, welcome back to Hub360 Embedded Sphere, your go-to spot for embedded projects and affordable electronics. Today we are building a wireless sensor data system using two ESP32 boards, the NRF24L01 module, a BMP180 sensor, and a 20x4I2C LCD display. You will learn how to transmit temperature and pressure data wirelessly, display live sensor readings on an LCD, and understand how the NRF24L01 handles wireless communication. All parts are available at hub360.com.ng, affordable, tested, and shipped nationwide. Let's get started. In this project, one ESP32 acts as a transmitter, reading temperature, pressure, and altitude from the BMP180 sensor. The second ESP32 is the receiver, displaying that data on an I2C LCD display through I2C communication protocol. Both communicate using the NRF24L01 2.4 GHz transceiver, so no Wi-Fi is required, just pure fast RF communication. Before we wire it up, let's take a closer look at the NRF24L01, the wireless brain of this project. The NRF24L01 is a 2.4 GHz transceiver made by Nordic Semiconductor. It can both send and receive data, making it ideal for device-to-device communication. The key features are a 2.4 GHz ISM band, license-free, data rate up to 2 megabytes per second, very low power consumption, and then 100 to 250 meters range, and up to 1.1 kilometers for the NRF24L01 Plus. SPI communication with the ESP32, that's what it uses. Now let's break down the pins. We have the VCC pin, and it accepts only 3.3 voltage. And then we have the ground pin, which shares common ground with the ESP32. Then we have the chip enable pin, CE pin, and it controls the TX-RX mode. Then we have CSN, which is the chip select NOT pin, which enables SPI communication. Then we have the SCK pin, which is the serial clock pin, and SPI clock signal. Then the MOSI pin, which is master out slaving ESP32 to NRF24 data. Then MISO pin, which is master in slave out NRF24 to ESP32 data. Then we have the IRQ pin, that's the interrupt pin. It's optional, often unused. The NRF24L01 sends small packets of up to 32 bytes. Here we send temperature, pressure, and altitude. Both modules must share the same address, like 0001, and channel to communicate. In short, the CE controls what the module does, that is in the TX or the RX. Then the CSN controls when the ESP32 talks to it. So now that we know how it works, let's wire everything up. The components used are two ESP32 development boards, two NRF24 modules, then jumper wires, and a 20x4 I2C LCD display. So now let's do the connections. Let's connect our BMP180 to the ESP32. So first, we connect the V-in pin to 5 voltage on ESP32. Then now we connect ground to ground. Then we connect the SCL pin on the BMP180 to pin 22 on ESP32. Now go and connect the SDA pin on the BMP180 to pin 21 on ESP32. So now we go on to connect the NRF24 module with ESP32. So first, we connect the VCC on the NRF module to 3.3 voltage on ESP32. Then we connect the ground of the NRF module to the ground of ESP32. Then we connect the chip enable pin on the NRF module to pin 4 on ESP32. Then next we connect the chip select pin on the NRF module to pin 5 on ESP32. Then next we connect the SCK pin on the NRF module to pin 18 on ESP32. Connect the MOSI pin on the NRF24 module to pin 23 on ESP. Then we connect the MISO pin on the NRF module to pin 19 on ESP32. And that is it. Now we connect the receiver side. First, we are going to connect our LCD here to the ESP32. Start by connecting VCC on the LCD to 5 voltage on ESP32. Now go ahead to connect the SCL pin on the LCD display to pin 22. Then we connect the SDA pin on our display to pin 21 on ESP32. Now go ahead to connect our NRF24 module to the ESP32. Start by connecting the VCC on the NRF module to ESP32 3.3 pin. And then we connect our ground on the NRF module to the ground on ESP32. Then we go ahead to connect the chip enable pin on the NRF module to pin 4 on ESP32. Then the chip select pin on the NRF module we connect it to pin 5 on ESP32. Then the SCK pin on the NRF module, we connect to pin 18 on ESP32. Then the MOSI pin on the NRF module, we connect to pin 23 on ESP32. Then the MISO pin on the NRF module, we connect to pin 19 on ESP32. And there you have it, your fully connected modules. Now in this project, we are going to need the following libraries. We need the SPI.h library, which enables SPI communication between ESP32 and NRF24LOI. Then we need the NRF24L01.h library and also RF24.h library, which handle all wireless transmission details. Then we need the wire.h library, which is used for the I2C communication with the BMP180 and LCD. We also need Adafruit's BMP085.h library, which reads temperature, pressure, and altitude from BMP180. Then finally, we need the liquid crystal I2C.h library, which controls our 20x4 LCD with simple print commands. Now let me explain the transmitter code. Now, in the radio and sensor setup, we define CE and CSM pins for NRF20L01, and then we use an I2C address. And then we use an address to pair transmitter and receiver, and then we also initialize the BMP180 sensor. You can see everything here. Then we go to the setup function. In the setup function, we begin serial and radio communication, and then we configure NRF24L01 for transmit mode, and then we initialize the BMP180 and check its connection. And then we go to the loop function. In the loop function, we read sensor values, and then we send both readings as an array through the NRF24L01. Then we print data to serial monitor for verification. Then, okay, that's that with the transmitter code. Now let's go through the receiver code section. In the receiver code section, in the radio and LCD setup, we assign the CE and CSM pins an address which must match the transmitter's address. Then the LCD initialize at I2C address 0x27. And then the setup function, we initialize the LCD and power its backlight. Configure NRF24L01 to receive mode. And then the loop function. We wait for incoming data. And displays received readings on both LCD and serial monitor in real time. And that's that with the code. Upload the transmitter code to the first ESP32. Upload the receiver code to the second ESP32. Pair both boards. Watch live temperature, pressure, and altitude data appear on the LCD wirelessly. And that's it, your own wireless sensor data system using ESP32 and NRF24L01. Send sensor data over RF, display readings in real time, perfect for IoT and remote monitoring projects. If you're enjoying this build, hit like and subscribe to Hub360 Embedded Sphere for more smart IoT tutorials. All components are available at hub360.com.ng. Tested, affordable, and shipped nationwide. Until next time, keep building, keep innovating.